In the arrangement of figure E1, the masses m0, m1 and m2 of bodies are equal. The masses of the pulley and the threads are negligible and there is no friction in the pulley. Find the acceleration W with which the body m0 comes down and the tension of the thread binding together the bodies m1 and m2. If the coefficient of friction between these bodies and the horizontal surface is equal to k, consider possible cases. So in this question, for the given system, we need to calculate the acceleration W with which the mass body m0 comes down and the tension in the thread connecting the mass blocks m1 and m2, and also we need to look for possible cases. So let's consider the case 1 in which the bodies are having the acceleration W. So in this case, let's start drawing the free body diagram of all the blocks to calculate the acceleration W. So initially let's draw the free body diagram of mass m0. The mass m0 is coming down with acceleration W and the forces acting on this mass are m0 g, the gravitational force vertically downward, T1 the tension force vertically upward. So we can write the equation of motion as m0 g minus T1 equals m0 W. Let's call this as equation 1. Now let's draw the one body diagram of mass block m1. The forces acting on the mass block m1 are the gravitational force m1 g vertically downward, the normal reaction n1 vertically upward, tension force T1 in the left direction and tension force T2 in the right direction, and a friction force F1 in the right direction. The acceleration will be towards left with the magnitude W. So we can write the equation of motion as T1 minus T2 minus F1 equals m1 W, and F1 will be equal to Kn1, where n1 is m1 g, and if you put the values of n1 in the equation 2b, we will get the value of f1, and if we put the value of f1 in equation 2a, we will get the equation 2 as t1 minus t2 minus k m1g equals m1w. Let's call this as equation 2. Now let's draw the one body diagram of mass block m2. The forces on mass block m2 are the gravitational force m2g vertically downward, normal force n2 vertically upward, and tension force T2 in the left direction. The acceleration will be in the left direction with magnitude W. The equation of motion for this block will be T2 minus F2 equals M2W. Let's call this as equation 3a. F2 will be K N2. Let's call this as equation 3b, and N2 will be M2G. So let's call this as equation 3c. If we put the values of N2 from 3c to equation 3b, we'll get F2 equals Km2g, and if we put the value of F2 from equation 3b to equation 3a, we'll get the equation T2 minus Km2g equals M2W. Let's call this as equation 3. Now let's put the value of T1 and T2 from equation 1 and equation 3 to equation 2. From equation 1 we get the value of T1 as m0 g minus m0 w, and from equation 3 we get the equation value of T2 as m2w plus k m2g. On putting the values of T1 and T2 we get the equation 2 as m0 g minus w equals minus m2 w plus kg minus k m1 g equals m1 w, or m0 g minus k m2 g minus k m1 g equals m0 plus m1 plus m2 w, or we get the acceleration w as m0 minus k times m1 plus m2 divided by m0 plus m1 plus m2 g. Now we need to obtain the tension T2 connecting the mass block M1 and M2. We have the formula T2 equals M2W plus K M2G. We already obtained the value of W as M0 minus K times M1 plus M2 divided by M0 plus M1 plus M2G. If we put this value of W in this equation, we get the value of T2 as M0 M2 G multiplied by K plus 1 divided by M1 plus M0 plus M2. In the equation, M0 plus M1 plus M2 can be considered to be equal to M, as it is given that the mass of all the three blocks are equal, and we get the value of T2 as K plus 1 multiplied by Mg divided by 3. So we get the tension force connecting the mass block M1 and M2, which was asked in the question. And we also look for the possible cases when the coefficient of friction is so high that there is no acceleration in the blocks. So in that case we can consider W to be 0, and we get the necessary condition only when T2 will be less than kmg, and T2 value is K plus 1 mg divided by 3. If we put this value in the equation, we will get K plus 1 mg divided by 3 is less than kmg. On solving this equation, we get the coefficient of friction will be greater than 0.5.